Hello there. Today we're going to be looking at the area of quadrilaterals that are a little bit more complicated than rectangles and squares. We're going to be looking at parallelograms, trapeziums and kites. It's kind of mid-range topic in area. It's not as difficult as things like circles and various other curved sided shapes, but it's obviously more difficult than simple squares and rectangles. So let's start with the parallelogram. There's a diagram of a parallelogram. The diagram's got three different measurements on there. Only two of those measurements are relevant to us. Watch out on exam papers because they will often give you an extra measurement just to see whether you know which ones matter and which ones don't. So the area of a parallelogram is base times height. It's as simple as that. The base is 6. Even if we straighten that parallelogram up, you can imagine that we could twist it so that it became a rectangle. It's still 6, both directions, top and bottom. So the 6 is important. The 5 is not important. The 5 is on the sloping side. Ignore the diagonal sides. It's the height of the parallelogram that actually matters. The height is 4. So what we're going to be looking at there is that the area is 6 times 4. So the area is 24 square centimetres. Just to make sure that you understand why that would be the case, a quick drawing of another parallelogram. And if you can imagine for a second that we could straighten up that parallelogram, we'd be taking maybe that side up there, and then it would automatically make this side become vertical. The 6 would still be there, the 4 would still be there. That would be like a straightforward rectangle. Obviously that little corner is cut off the parallelogram, but this corner is added on to the parallelogram. They're both the same size as each other, so it's exactly the same as treating it as though it's a straightforward rectangle. Okay, so area of a parallelogram, base times height, straightforward. Just remember to never take notice of the diagonal because that is not relevant to the area. Okay, would be relevant to the perimeter but not to the area. Now, moving on to the trapezium, that's a little bit more difficult. So let's just take a look at this one. The trapezium is a four-sided shape with two parallel sides and two sides that are not parallel. So on this one, the top and bottom are parallel with each other, and then the other two sides are not parallel. Now those two not parallel sides don't have to be like the ones I've drawn here. You could have a vertical one and a sloping one. You could have completely different slopes on them, but it's four sides, two parallel, two not. The area calculation is related to triangle kind of ideas, because if you think about this, it's a little bit like a rectangle with two triangles stuck on the end of it. So that's a kind of clue that there's going to be a half in there, because you know that the area of a triangle is base times height divided by 2. So in that case, we're going to be using this half to deal with these triangles. The area is half of A plus B times the height. A and B are the two parallel sides. It doesn't matter which one is A and which one is B, but they are the two parallel sides. So what we're saying here is that it's half of 8 plus 12 times the height, which is 6. It wouldn't matter if we'd got a measurement on a sloping side, we would ignore it again. It's not relevant to us. It's the verticals and the horizontals that matter. Multiply out those brackets, so that's 20. 8 plus 12 is 20 times 6, and we want half of that. Okay, 20 times 6, 2 6s are 12, so 26s are 120. Half of that is 60. Okay, So 8 plus 12 makes the 20, times 6, and then half it all. Now you could do it a different way round. Let me just put a little bit in this corner here, just in case you're wondering, is there a specific way to do it? You could have done 8 plus 12 makes 20, and we could have had half of 20 times 6. We could have started by doing half of 20. Half of 20 is 10 times 6, which still equals 60 square centimetres. Whichever way round you do it, you're going to get the same answer. So don't worry about there being a specific order to it. So it's half of the A plus B, the two parallels, and then multiply it by the height. Okay? So that's a trapezium, and basically those halves are related to the fact that we have triangles. Triangles stuck to the edges of the trapezium. Alright, so that's the trapezium. Now the final one that we're going to look at is the kite. There's a kite, quadrilateral with no parallels, two long sides, two short sides. And the lengths of the sides are absolutely irrelevant when we do the area of a kite. Completely irrelevant. What we need to know is we need to know the diagonals in the kite. We need to know the two longest sides. So that's one of the longest sides, which we're going to call A, from point to point there. And then the other longest side is B, which is from point to point here. And the area formula for this one is that we multiply together A and B, and then we half it. Okay. Again, the halving aspect is because it's lots of triangles. It's basically two triangles here on this side, which are part of a bigger shape, a bigger rectangle. Two triangles on this side, which are part of a bigger rectangle. So in here then, I've given you an example of what the lengths would be. So A times B is 10 times 6 over 2. 10 times 6 is 60 over 2. 60 divided by 2 is 30 square centimetres. Okay, and basically that's what we do there. So any information about the lengths of the sides are not relevant again to you. As I said before, they are for perimeter, but they're not when we're dealing with the area. So the area, we need to know how long and how wide the shape is from its largest points, its longest points. Okay? A times B divided by 2. So that's the area of the three difficult shapes: parallelogram, trapezium and kite. If you want practice, take a look in the workbook. Search on Amazon, Maths is Not a Mystery, and you'll be able to find a workbook with some examples in there. Some of the examples have got sneaky little extra numbers in there that you've got to try to remember to avoid. And of course in the worked examples, the answers tell you what you should have taken notice of and what you shouldn't have taken notice of. Okay. If you want to go for more difficult stuff, we've got videos about circles and other curved-sided shapes there for the higher paper. Thank you for watching Maths is Not a Mystery, and we'll see you soon. Goodbye.